This is the second gas law that actually is the oldest gas law that I'm making. In this video, the gas law, Boyle's gas law, dates to about 1662. And Robert Boyle was the 12th or 13th child of the most wealthy person in Ireland. He lived a privileged life, personal tutors, learned foreign languages, traveled a lot with his tutor, and he got involved with a lot of different fields. In the field that we're talking about is the gas laws. He was an experimental person, and he wrote a book called The Skeptical Chemist. And he's really, some people like to call him as maybe the father of chemistry, paralleling Antoine Lavoisier from France. But Boyle at that time knew basically that you're dealing with gases, you deal with a quantity of gas. The word mole was not used, but he is a particular quantity of gas. And he knew that you could manipulate volume, which is usually in liters. Another variable of gas was temperature. And we found out that temperature is in Kelvin. And finally, pressure. Could be in atmospheres, millimeters of mercury, kilopascals, torr. So, Boyle's one of the first experiments was with a manometer, and it's shown here at the left. And you'll notice in the manometer, it's just an open tube. It has air in it, of course. You pour some mercury in it, and you get a level of the mercury, and you get a volume of gas on the left that you can measure. In this case, it's about 60 milliliters. And then if you pour more mercury, you've increased the pressure on the right, and you can have the volume of gas decrease. So the second graph is he discovered that pressure and volume are inversely related. And now the mathematics of inverse is important. And we look at the next graph, we see that if you take a point P1, V1, you get 50 milliliters of volume, and 50 kilopascals is a pressure, and you get a volume of 6 liters. Well, if you multiply these together, notice the pattern here. We always look for patterns in graphs and data. The product of 50 times 60, 50 times 6, is 300. Well, if you take another point, P2, V2, you have 100 kilopascals, 3 liters, the product is 300. Steal another point, P3, V3, you have 150 kilopascals, 2 liters, and you have 300. So Boyle's law was simply that pressure times volume equals a constant, and that's only when you have a fixed number of moles or amount, because if you increase the moles, you're going to increase the volume. And also to keep the temperature constant. If you increase the temperature, you're going to increase the volume. These are called confounding variables, so you have to hold 2 of them constant. All right. Now let's look at the mathematics here. If we can say P1, V1 equals a constant, and P2, V2 equals that same constant, if these two things are equal to the same thing, they're equal to each other. Therefore, P1, V1 equals P2, V2. Now, this is Boyle's law in a change situation. And we'll take a problem up here. That the problem is if you start with we'll just make one up here. Let's see. We start with initial pressure of 1 atmosphere. And we increase the pressure on a gas to 5 atmospheres. And if we start with initial volume of a gas of 100 milliliters. Now notice you can use any units for volume here, milliliters, cubic meters, or liters, because they're going to cancel out. I'll show you. The new volume is a question mark. So if we're solving a problem, P1V1 equals P2V2. The first thing I say is to always set up your equation for the solve for your unknown. Your unknown is V2. So we're going to multiply both sides of this equation. Keeps the same value by P2. Now we have V2 equals P1V1 over P2. Substitute our quantities. P1 is 1 atmosphere. V1 is 100 milliliters. And P2 is, we've increased it to 5 atmospheres. So you can see atmospheres cancel out. And our answer is 20 milliliters. So it makes sense. Pressure and volume are inversely related. Inversely related. You could use this for any 3 variables given. You could solve for the 4th one. You could solve for P1, V1, or P2, V2, given the other 3. All right, we will stop right there, and this is the law called Boyle's law relating pressure and volume, holding moles and temperature constant.